And right now it's in a nice form where it's y equals for both equations. So I go to y equals. I type in negative x squared minus 3x for the first equation. And x squared, subtract 1 for the second. In the past, a few mistakes I've seen students make is they don't put a negative here, they put a subtraction. This is a negative out front, bless you. And these are subtractions right here, bless you. Go to graph, let's see if we can see the intersection points. We have a parabola that opens downward and a parabola that opens upwards. Okay, I can see two intersection points. So second, trace, intersect. It is hard to see this. I'm going to do something just to show it. You could do it here, but there's one intersection point. Sorry, there's one of the curves or the functions. I press enter, it jumps to the second, and move off. I press enter again. I go over the top of where they intersect and I press enter. So one intersection point, and I'm going to have you round to the nearest tenth. As a reminder, we look at the second number. Because it's 5 or greater, I bump up 0.3. And over here, I have a negative 0.9. Hands up high if you've been able to find that one, just so I can see it. Awesome. Okay, I'm going to find the second one. Second, trace, intersect, enter, get closer, enter, and over the top of the intersection point. The second one, rounded, is a negative 1.8 and 2.2. Now this is a great example. Can everybody do me a favor? Can everybody hit second graph so we can look at the table? If you simply looked at this table, it would appear like there's no intersection points because there's no x values that have a corresponding y values for both functions that's exactly the same. Even though we do have x values with corresponding y values that are exactly the same, because these are not pretty integers, it would not show up on the table.